All right, welcome to 1.8, Valence Electrons and Ionic Compounds for AP Chemistry and the end of Unit 1 concepts. All right, 1.8 does not have any equations. It's really, again, concepts like the previous 1.7 periodic table trends. But this gets into just the outer shell electrons and binding energy of those electrons. So this is pretty short. So ionic bonds always form with the transfer of electrons from the least electronegative species to the most. So that's how ionic bonds, we learned in regular and honors chemistry, it's just a transfer of electrons, but it's always from the least electronegative to the most electronegative, all right? And then from your periodic table, starting left to right, valence electrons in each group. So we have group 1 has one valence electron, so they form one positive. They want to give away their electrons because they're the least electronegative. Group 2 has two valence electrons, so they form positive 2 cations. They also want to give away their valence electrons. And then we don't deal with the D or the F group. We totally jump that. Group 13, if you have a 13 on your periodic table, that's actually group 3, and they form 3 positive ions. They're cations. They want to give away their electrons. Now, once we get to group 14 or group 4, it's got a positive, and I'm going to put positive 4 and then slash negative 4, because in group 4, you've got some nonmetals that want to gain, and you've got metals that want to give away the valence electrons. So that's why it's plus minus 4. Group 15, 5, this is where we start with higher electronegativity, and group 5 is negative 3. They want to gain electrons. Group 16 or 6 is negative 2, and then group 17 or group 7 is negative 1. The noble gases are stable. They don't want any more valence electrons. 8 is the magic number, or helium with 2. So that's why these numbers go down, because group 5 only needs 3 more electrons. 5 plus 3 is 8. Group 6, it only needs 2 more electrons to get to noble gas, and group 7 only needs 1 more. Okay, so they want to gain enough electrons to fill their outer octet. So valence electrons want to be stable at 8 or 2 for helium. Okay, and that's really the notes. All elements want to maintain neutrality, so they've got to gain or get rid of electrons to get to a stable octet. So calcium reacts with a certain element to form calcium X2. What would be the most likely formula for a compound between sodium and X? Well, because calcium wants to give away 2 electrons, that means X is a negative anion, so those bond, and we got to assume 1 because we have 2X to every 1 calcium, and we learned if we cross our charges, we get our subscripts, which gives us KaX2. So with that, sodium is positive 1, X is negative 1, so we don't have to change anything or crisscross our charges because it's the same. So D is the correct answer. Okay. All right, let's flip this over. If we had element 117 is Tennessean, assuming periodic trends are followed, write the noble gas configuration, and predict the formula when it forms with magnesium. All right, so have a periodic table out and find Tennesseum. You're going to find that it is all the way down and all the way to the right of the periodic table, and that's why we're going to do the noble gas configuration, because it is way down there. That would be a lot of numbers to get through. So noble gas configuration is the noble gas in the period right before, so radon. Oh, oops, it's TS. So we got radon. So that gets us through period 6. So 7s2. Okay, so we got 7s2. And then I know on the periodic table we've got this 1D here, okay? But when we are in where we're going to have to use F, we put F first. And remember, the F group is 2 energy levels behind. So if this is 7, then down here in this bottom is going to be 5. So 5F. And there's 14 elements to get through, so 5F14. Then I come back up to the D, and D is also an energy level behind, so that's 6. And that's 6D 10, because we got to go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're at 7P. We're at the P group. 1, 2, 3, 4, 5. Okay, so we get 7P5. Now, in the video, she does talk about how she teaches her students to go back and put it in numerical order. So put radon and then the 5F, the 6D, the 7S, and the 7P. I do not teach that. That is not the correct order. You need to put the electron configuration based on Hun and Abafo's rules, okay? So don't worry about the numerical, okay? Now, it says if periodic trends are followed, what would be the formula for tennessium and magnesium? Well, we know magnesium is in group 2, so it's got a positive 2. Tennessium is here in group 17, which is group 7, which forms a negative 1 charge. So we can make that prediction that TS is negative 1. If I cross my charges, I get MgTS2. And that would be the formula if it bonded with magnesium. Okay? All right, let's go over the you-dos. Which of the following has the same number of electrons as chlorine negative 1? And explain why. So chlorine here is being shown as an ion. Chlorine has 17 protons, and it gained an electron. So which one would match that? Circle it and explain why. Number 2, potassium chloride dissolves in water. It forms a solution that is able to conduct electricity. Which of the following would behave similarly? So if KCl dissolves, it's going to break into its positive and negative cations and anions. So we have charged particles. So that's why it conducts electricity. That was the lab that we did in regular and honors chemistry. So which of these would behave the same way? And if it's more than one, explain that. Number 3, complete the photoelectron spectroscopy graph for the element shown. Which oxide compound would it most likely form? So kind of go back to 1.6 and review your notes to figure out this is the higher energy, this is the lower. We got to assume if this is the highest energy, this must be an S, and this must be possibly another S group. And then which one would it form? Identify the correct electron configuration for the aluminum ion, so Al3+. And that is your notes for 1.8, valence electrons and ionic compounds, and I will see you in class.